Assalamu alaikum everyone. Today we are starting chapter 2 which is all about data governance and management. Now before I define data governance, let me ask you a question. Imagine a company, let's say a bank, has millions of customers. Each customer has records like their name, their CNIC number, their bank balance, their loan details, and their ATM transactions. Now, think what would happen if this data was not properly managed? Well, without rules, one branch might record balances in one format, another branch in a different format. Some records might be duplicated, others incomplete. Maybe someone could even tamper with the numbers. Can such a bank survive? No, the entire system would collapse, right? This is exactly why we need something called data governance. The word governance itself means setting rules, defining responsibilities, and ensuring things are done properly. Just like how a government sets laws for its citizens, data governance sets rules for how an organization's data should be handled. So, in simple words, data governance is the framework of rules, processes, roles, and technologies that ensures data is accurate, secure, consistent, and used properly throughout its life cycle. Notice that definition carefully. It's not just about technology, it's about people, processes, and tools all working together. Let's break this down slowly. First, it ensures accuracy. Data must be correct. Imagine a salary slip showing rupees 50,000 instead of rupees 500,000. A single missing zero changes everything. Second, it ensures consistency. A customer's phone number should be the same whether you see it in the marketing system, the sales system, or the finance system. Third, it ensures security. Sensitive information like health records or credit card numbers must only be seen by the authorized people. And fourth, it ensures compliance. Governments and regulators now have strict laws about how data is stored and used. Non compliance can result in huge fines. And finally, it ensures value because data is not just information, it's an asset. If managed properly, it can drive better decision making, innovation, and efficiency. Without governance, data becomes a liability, and with governance, data becomes an asset. Now, data governance is not one size fits all, it operates at three levels: strategic level, tactical level, and operational level. Strategic level is the big picture. Senior management defines the vision and goals. For example, they may decide our organization will protect customer data as if it were money. And tactical level, here managers and IT teams create policies and procedures to make that vision a reality. And operational level is the ground level where employees and systems enforce rules every day. For example, a teller verifies a CNIC before opening an account, or a database automatically rejects an invalid phone number. Think of it like a cricket team. The board sets the long term vision, that is strategic, and the coach creates training plans, that is tactical, and the players follow the rules on the field. It's operational. Let's go back to our bank example. At the strategic level, the bank decides we want to be the most trusted bank for data security. And at the tactical level, IT managers say we will enforce two factor authentication for online banking. And at the operational level, customers log in with both their password and an OTP every time they use the system. Do you see how governance flows from top to bottom? Components. I want you to listen carefully because these are exam favorites. Number one, data ownership and stewardship, like who is responsible for the data. And number two is policies and procedures, like the rules and standards. And number three is data quality management. like keeping data accurate, complete, and timely. And number four, data security and privacy, like protecting it from unauthorized access. Number five is compliance and risk management. It is ensuring laws and regulations are followed. And number six, metadata management. Remember, that's data about data. And number seven is life cycle management. It's from creation to usage, and then usage to storage, and then storage to archival, and then from archival to deletion. Each of these components is like a pillar. Remove one, and the entire governance structure becomes weak. In 2017, Equifax, a credit bureau in the US, suffered a massive data breach. Hackers stole personal data of 147 million people, like names, addresses, social security numbers. Why? Because Equifax failed to patch a known security flaw. This was a governance failure. The result, a loss of customer trust, lawsuits, and billions in damages. Now, contrast this with Apple. Apple treats customer privacy as a selling point. They have strong governance policies about what data is collected, how it is stored, and what can never be shared. As a result, customers trust Apple more. And governance, therefore, isn't just about avoiding disasters, it's about building reputation and value. So, whenever you think of data governance, think of it as the rule book that transforms raw data into a trusted organizational asset. Alright, now that we know what data governance is, the first step in actually applying it is to ask what kind of data are we dealing with? Because remember, not all data is equal. Some data is harmless if leaked, and some could destroy a company if exposed. This process of sorting and labeling data is called data classification. Why data classification matters? Think about your own life. You share your name publicly. You may share your phone number with friends and family only, but not with everyone. But your bank pin or medical records are private and secret. Organizations are the same. They must classify their data so they can apply the right level of protection. If you treat everything as highly secret, you waste resources. If you treat everything as public, you may expose yourself to risk. So, classification creates balance. The golden rule is different data requires different levels of care. Now, let's carefully go through the four main categories. Public data is safe to share openly, while internal data is only for employees. If leaked, damage is limited. And confidential data is sensitive and restricted to authorized staff only, while restricted data is the top level sensitivity. Exposure can cause severe legal or financial harm. Organizations use different models depending on their needs. Remember, classification simply means putting data into categories based on how sensitive it is, who should access it, and what rules apply. Think about how in your own home you keep some things openly, like your shoes near the door, but some things are locked in cupboards, like your jewelry or important documents. That's exactly what organizations do with their data. They classify it so they know how carefully it should be protected. Sensitivity based model. This model classifies data based on how sensitive it is, like how sensitive the data is to the organization. And it includes categories like public, internal, confidential, or restricted. Public, like company website, everyone can see. Internal is like employee phone list, only staff should see. And confidential is like customer records, like only HR, finance should see. And restricted is like trade secrets or formulas. Only a few people, maybe the CEO, can see. It is like different locks in your home. Some rooms are always open, and some have a simple latch, and some are double locked with a safe inside. Role based model. It is like access is given based on your role in the organization, not on who you are personally. Like an executive can access company wide strategy documents, while a manager may access team performance reports. Similarly, a staff member can only see documents needed for their job. Think of a hospital. Doctors can see patient medical records, nurses can see treatment charts, but the receptionist only sees appointment schedules. Same hospital, same data, but roles decide the level of access. Compliance based model. This model is guided by laws and regulations. Organizations don't have a choice. They must classify data in certain ways because the law requires it. Under GDPR in Europe, personal data like names, phone numbers, or email addresses must be tagged and handled carefully. This is like traffic laws. You may want to drive fast, but the law forces you to follow speed limits. Similarly, organizations may want flexibility, but compliance rules force them to classify and protect data in certain ways. Life cycle based model. Here, classification depends on the stage of the data's life. And for example, different stages are draft, active, archived, or deleted. Draft is a report being written or work in progress, may not need full protection yet. And while active means like it is finalized report being used and needs strong protection. Archived, like is old project files stored for record keeping and protected but rarely accessed. Deleted is when no longer needed, and destroyed securely, shredded digitally also. Think of a student's exam answer sheet. While writing, it's a draft. When submitted, it's active, and after the year ends, it goes to archives. After a few years, it's destroyed. Government-based model. This is common in defense, military, and government agencies. They have very strict layers of classification, and typical levels are like unclassified or restricted, confidential, secret, and top secret. Where unclassified is like press releases and say it is safe for the public. Restricted, like internal memos and only for staff. Confidential is like embassy communications, and secret are like military plans, and top secret like nuclear launch codes. Think of spy movies. Not everyone can see the files. Only people with the right security clearance can open the folder. See how classification ensures the right balance between accessibility and protection. Alright, now look at data storage. We have talked about governance and classifications like rules and labels, but rules and labels are meaningless unless the data is stored somewhere safe and accessible. Imagine this, you write all your notes but never keep them in a bag, a drawer, or a shelf. What happens? They get lost, torn, or mixed up. The same happens with the organizational data if there is no proper storage system. So, today we will learn about data storage, where and how data is kept, both physically and digitally. Why data storage matters? Data is only useful if it is stored securely, safe from theft or damage, and it is accessible when needed, and it is organized logically and easy to find. Think of it like a library. If books are scattered all over the floor, even the most valuable book becomes useless because you can't find it. Proper storage is the backbone of data governance. Now, let's break down the main types of storage that organizations use. On-premises storage is like the company keeps its servers in-house, and data is stored in physical data centers or server rooms owned and managed by the organization. And it has some advantages like full control over security. Data never leaves the premises, and good for highly sensitive or restricted data. Uh, Also, it has some disadvantages like very costly buying servers or cooling systems, and backup powers are costlier and requires a specialized IT staff. And also, scaling up is slow. You have to buy more hardwares. Banks and defense organizations often prefer on-premises storage for maximum control. Number two is cloud storage. Data is stored on remote servers owned by third party providers like Amazon or Google Cloud. And it also has some advantages like flexible and scalable, accessible from anywhere with internet, and also lower initial cost. With this, it also has some disadvantages like dependent on vendor and internet. Data may be stored in another country, which raising compliance issues and risk of vendor lock-in, like hard to move data elsewhere. Small businesses, startups, and e-commerce platforms often use cloud storage because it's affordable and flexible. And number three is hybrid storage. It is the combination of on premises and cloud, and sensitive data kept on site, less sensitive or high volume data stored in the cloud. For example, a hospital may keep patient records on premises but use the cloud for research data analysis. Now, let's look at some emerging trends that are changing how data is stored today. Edge storage, where data is stored closer to where it's generated. Like Internet of Things devices like smart cameras store footage locally before sending to central servers. And blockchain based storage, where data stored in decentralized blocks, making it tamper proof, useful for financial records. Data lakes, where large repositories that store both structured and unstructured data in raw form, like social media posts, sensor data, and it is very popular for analytics. Cold storage, where data that is rarely accessed, like old transaction logs stored on cheaper, slower media to save costs. Let me give you an example from e-commerce. During Black Friday, traffic to online shopping sites increases by 10x. If they only had on-premises storage, servers would crash. Instead, they use cloud storage to automatically scale up during high demand. Once sales are over, they scale down to save cost. Without flexible storage, they had lose millions in sales. So, to summarize, data storage is where and how data is kept securely and logically. Main models are like on premises, cloud, and hybrid. There are also some emerging trends like edge, blockchain, data lakes, and cold storage. Storage is always about balancing control, cost, and convenience. Without proper storage, governance rules cannot be enforced because data has no secure home. Data integrity. Let me ask you this. If you cannot trust the data you're looking at, then what is the point of storing it, securing it, or even analyzing it? Imagine you are an auditor and you are given a balance sheet, but some numbers are missing, others are duplicated, and one entry shows a company paid rupees 10 million when in reality it was only rupees 1 million. Would you trust that balance sheet? This is where data integrity comes in. What is data integrity? Simply, data integrity means keeping data accurate, consistent, and reliable over its entire life cycle. If data is corrupted, tampered with, or entered incorrectly, it loses its value completely. Without data integrity, governance collapses because governance is only as strong as the quality of the data it governs. There are two main types we need to understand: physical integrity and logical integrity. First, look at the physical integrity. It refers to the protection of the physical storage of data, and it often face some threats like power outage, hardware failure, natural disasters, server damage. Solutions are like backups and redundant servers and disaster recovery systems. If a company's data center is flooded, physical integrity is at risk. Now, logical integrity refers to the correctness and consistency of the data itself, ensures that data is valid, accurate, and makes sense. It also has some threats like human errors, cyber attacks, poor database designs, and which can be mitigated through validation rules, constraints, and through encryption or error detection. If a system allows a customer's age to be entered as 300 years, that violates logical integrity. Let's go deeper here. What are the major threats? Human error, like mistakes in data entry, typing error, duplications, omissions, cyber attacks, like hackers may tamper with or alter records. Hardware or software failure could corrupted files, crash servers. Similarly, poor database design is like allowing illogical or inconsistent entries. Unauthorized access is where employees deliberately altering data. How to preserve data integrity? Organizations use several methods like access control. Only authorized people can change sensitive data. Audit trails like logs showing who changed what and when. Validation rules is like ensuring data entered is logical. Data cannot be in the future. So backups and redundancy is like having copies in case of corruption, and encryption is like protecting against tampering during transmission. Imagine a hospital lab system where test results are accidentally entered under the wrong patient's name. This could lead to a fatal misdiagnosis. That's why data integrity is critical in healthcare. If a bank's database mistakenly doubles a transaction due to system failure, it affects customer trust and legal compliance also. Without integrity, data is just noise, not information. Data security. Let me ask you what happens when data security fails. So far, we have studied governance, classification, storage, and integrity. But even if all of those are in place, data is still vulnerable unless it is protected. The protection is what we call data security. What is data security? In simple words, data security means protecting data from unauthorized access, misuse, theft, corruption, or loss while ensuring it is available to the right people at the right time. Notice the balance here. On one side, you must restrict access to keep intruders out. On the other, you must allow access to those who genuinely need it. To understand data security, we use a famous model called the CIA triad: confidentiality, integrity, availability, where in confidentiality is ensuring that only authorized people can access the data, like only HR staff can see salary records. Integrity is ensuring data is not tampered with or altered improperly. Like a customer's account balance must not be changed by anyone except authorized staff. And availability is like ensuring data is accessible when needed. For example, ATMs must be available 24 by 7. Together, these three make up the foundation of data security. Methods of securing data. Now, how do organizations actually achieve this? Let's go step by step. Authentication and authorization is verifying identity like through passwords, OTPs, biometrics, and granting access based on roles like role-based access control. Encryption is converting data into unreadable code so outsiders cannot misuse it. Even if hackers steal encrypted data, it's useless without the key. Firewalls and intrusion detection systems, simply IDS or IPS, is like firewalls block unauthorized traffic, and IDS or detect suspicious activity and stop it. Backup and disaster recovery system is like creating copies of data to recover in case of attack, corruption, or natural disaster. And physical security is like locked server rooms, ID cards, CCTV, and restricted access to data centers. Employee awareness training is also equally important. Like many breaches happen because employees click on phishing links, and training staff reduces human error. Think of data security like protecting a house. Locks on doors or windows is equal to the authentication and passwords. Similarly, alarm system is equal to the intrusion detection, and CCTV is equal to the audit logs. Insurance policy is equal to the backups and disaster recovery. Educated family members are also equal to the employee training. All of these work together. If even one is missing, the whole system can fail. So far, we have learned about data governance, classification, storage, integrity, and security. These are all systems, rules, and tools. But here is the key question: who actually makes sure these rules are followed? Because let me tell you, no matter how strong your policies are, if nobody is responsible for enforcing them, they are just paper. This brings us to data stewardship. In simple words, data stewardship means assigning responsibility to specific people called data stewards who ensure that data is accurate, consistent, secure, and compliant in everyday practice. Think of governance as the rule book and stewardship as the referees who enforce it during the match. Without stewardship, governance is only theory. With stewardship, governance comes alive in practice. Data steward is not necessarily a senior executive or IT engineer. It could be anyone trusted with maintaining the quality and proper use of data. Their responsibilities usually include maintaining data quality, like ensuring data is accurate, complete, and updated. For example, checking that no customer record is missing contact information. Enforcing policies, making sure data classification, storage, and security rules are followed. For example, preventing staff from emailing confidential files to personal accounts. And training and awareness is like teaching employees how to handle data responsibly. For example, conducting a workshop on phishing awareness. And compliance monitoring is like checking that legal and regulatory requirements are met. For example, ensuring GDPR right to be forgotten requests are processed. Data documentation is like managing metadata. For example, clearly documenting what customer ID means in the database. Governance is like what should be done, and it's the rules and policies. While stewardship is like making sure it is done, so it's execution of those rules. In cricket, the ICC sets the rules, that's the governance, but the umpires enforces them on the field, that's the stewardship. Now, consider a hospital where governance policy is patient records must be updated immediately after consultation. And stewardship role is like a nurse or admin staff ensures the doctor's notes are entered correctly into the system. Without that steward, the policy would just sit in a handbook. Why is stewardship so critical? Because data is handled daily by employees, not just by management. A single careless mistake, like entering the wrong decimal point, can ruin reports, audits, or even cause legal issues. So, stewards act as guardians at the ground level, preventing these mistakes. So, data stewardship is a responsibility for enforcing governance in practice, and stewards maintain quality, enforce policies, train others, monitor compliance, and manage documentation. Governance is the law book, while stewardship is the enforcement. Similarly, without stewardship, governance cannot succeed. In a nutshell, good governance requires good stewards. That's all for this lecture. In next lecture, we will continue from this. Till then, Allah Hafiz.